Welcome to Unit 2, which is all about the moles and how to calculate something called molar mass. By the end of this video, you should be able to calculate the molar mass of an element or a compound. If you don't remember what an element or a compound is, make sure you look back in Unit 1 and determine what those are before you go forward. So when we talk about moles, we're not talking about this type of mole that lives in your garden, cute though he may be. We are talking about more of a mathematical idea. And basically, the mole represents a specific amount of any substance. We use it to talk about atoms and molecules because there are so many of them, and even the tiniest amount of a chemical or even a drop of water just has billions upon billions upon billions of molecules of water. So scientists had to come up with a better way to count that instead of trying to deal with huge numbers and count them individually. So they came up with the mole. And the mole basically measures 6.02 times 10 to the 23rd particles. And if you look down here at the bottom, that's that written out in a regular number instead of scientific notation. And you wouldn't want to have to count that every time you did any chemical calculation. You'd go insane. So we use mole to equal this many particles. Just like we use the word dozen to equal 12. So a dozen donuts is 12 donuts. A dozen eggs is 12 eggs. A dozen atoms would be 12 atoms. Well, a mole is the same type of thing. A mole of pizzas would be 6.02 times 10 to the 23rd pizzas, or a mole of donuts would be that many donuts, just like a mole of atoms is that many atoms. Basically, a little history. The mole is based on the fact that 12 grams of carbon-12, which is a specific type of carbon, has a mole of atoms. So if you were to weigh out 12 grams of carbon, there would be 6.02 times 10 to the 23rd atoms in that gram, if you could count them out. So, and particles is a good way to describe that because we're not just talking about atoms. We can be talking about atoms, molecules, anything. Just like a dozen doesn't specifically refer to donuts. It refers to anything that's 12. Same with a mole. Anything that has this many particles is a mole. So when we talk about molar mass, which you'll sometimes see referred to as gram formula mass or molecular mass, that is how much 1 mole of a substance weighs. So we use this conversion factor to go between different chemicals in a chemical reaction. But basically, this is how much a mole of something weighs. Just like when we did our density experiment, the different things weighed different amounts, right? So a mole of oxygen does not weigh the same as a mole of gold, or a mole of zinc, or a mole of water, or a mole of salt. They all will weigh different depending on what they're made up of. The way that you calculate the molar mass, it's actually easy with elements because they're just written right on the periodic table. So if I click over to my periodic table here, I'm not sure I can do that. Anyway, on the periodic table, I will figure out how to show you one. You can see the amount, how much a mole of each element weighs. All right, so I got me a little periodic table, and it's really hard to see, but and it's backwards, but that's okay. The number above the symbol is the molar mass of that element. So when you go to look at the periodic table, the number you're looking for is that number above the abbreviation. I know it's backwards, but for helium, it's 4.003. That is the molar mass of helium. How much 1 gram of helium weighs. Oh, well, look here. This looks a little bit easier right here. So the molar mass of an element can be found on the periodic table. It is actually the number that is above the abbreviation. So you see here this little portion of the periodic table, this number above the abbreviation. So for iron, that first question says the molar mass of iron is 55.845. Um, we will always round that, and actually we will round it to 2 places past the decimal, unlike this, which is just 1 place past the decimal. But always round that to 55.85. And please remember to put in the units. It is grams per mole. So anytime you write the molar mass, you have to write it as grams per mole. And then the molar mass of copper is Cu, so it's this one over here. So it would be 63.55, because we round up, grams per mole. And again, don't forget, you always have to put the units when you write anything. For compounds, they're a little more complicated. You have to do some addition, but you have to add up the molar mass of all the elements that are in that compound. So if we talk about the molar mass of water, water has hydrogen and oxygen in it. So we take the molar mass of hydrogen, which is 1.00, and we multiply it by 2, because there are 2 hydrogens in this water molecule. And then we add to that the molar mass of oxygen, which rounds to 16, because it's 15.9994. So that rounds to 16.0. There's only 1 oxygen in water, so we only add it in once. When we add those up, we get 18 grams per mole. So the molar mass of water is 18 grams per mole. We can get into a little more complicated things, like calcium chloride. We know it's going to have calcium. We know it's going to have chlorine in it. The formula for this, which should be written out there, is actually CaCl2. So there's 1 calcium, so that's the 40.08, and 2 chlorines for the chloride, which is the 35.45 times 2, because there's 2 of them. When we add that all together, we get 110.98 grams per mole. Don't be too concerned right now that you didn't know that there were 2 chlorines in that. I will always make that clear to you. So that's how you calculate the molar mass of either an element or a compound, just straight from the periodic table, and do some addition if it is a compound.